Hey folks, in this video, I want to talk to you a little bit about second class levers. We've already talked about first class levers, and I wanted to keep going with that. So let's go. So first thing is I have a couple of things, right? I know my actual mechanical advantage, I know my force effort, and I know my distance effort. Best thing to do first, right out of the gate, is to draw this thing. So it's a second class lever. And my little mnemonic device is free, 1, 2, 3. So first class lever is F, or fulcrum in the middle. Second class lever is resistance. So I know my resistance is in the middle. Well, that means my fulcrum is on one of my ends. My resistance is in the middle. A resistance force is going to pull down towards the earth. I don't know anything about it if I look over here on the left at my givens. So I'm just going to write force resistance, FR. Then I know my distance and force effort. So that is going to be going up because my lever is not moving, so they both can't go in the same direction. Force is of resistance going down, force effort is going up, and that's going to equal, in this case, 6 newtons. I'm going to label my distance now from my effort to my fulcrum, because I know my DE is 4 feet. We'll assume feet. I didn't write feet, but that's what I meant. It's not like it really matters at this point for us anyway. All right, 4 feet. Do my little arrows here. Cool. There's something I don't know, though. I'm going to put that in red, actually, and that's up here. That's going to be my, distance resistance. I don't know how far apart or far away my resistance is from my fulcrum. So I need to do some math for that, don't I? There's a couple things I don't know, but I was given actual mechanical advantage. Maybe I can use that because actual mechanical advantage, AMA free. Oh, okay. So I know that. That's a actual mechanical advantage is 3. My force resistance, I don't know that. Force resistance. I do know my force effort is 6 newtons. Okay, well, I can cross multiply here to solve for my FR. Multiply both sides by 6 newtons. And 18 newtons is my force resistance. Sweet. So I know that. I'm going to come up here. I'm going to tweak this. I actually don't need to draw that line through it. But this is now 18 newtons. Awesome. But I need to know my distance resistance still. So I probably needed to use another formula. So let's use the static equilibrium formula, or the sum of moments equal each other, or equal 0. So if my moments created by effort plus my moments created by resistance have to add up to be 0. All right. So my force, or my moment for effort, is 6 newtons times 4 feet plus my moment of resistance. So 18 newtons, but its arrow is going down. I'm doing this slightly different than I did the last one, right? Because last one I said moments equal to each other, which is still true. But it's a negative 18 newtons because that arrow is going down. My distance, I don't know. So that's just distance resistance still equals 0. This is how it still all works out, right? One of my forces is positive. One of my forces is negative. So we're all still good and dandy. Let's multiply these two things. So I end up with 24. I'm going to drop the unit for a minute. Minus 18 times distance resistance equals 0. Let's solve for dr. So I need to add over my 18 newtons, or 18 times distance resistance. Divide both sides by 18. Well, this fraction reduces a little bit, doesn't it? So I'm going to write off to the right now. Dr equals 24 over 18. I can divide both of those by a 6, and I end up with 4 over 3. 4/3 as a decimal is 1.3. Go team. And this is feet. Not too bad, right? So first, I found out whatever I could using the givens. So my force effort and distance effort didn't really give me a whole lot, so I went to my actual mechanical advantage then. It provides me with quite a bit of information. That found me my force resistance, which I then substituted in, I wrote that in there. Actually helps me to have that picture. Then I only needed to figure out my distance resistance, and I used my static equilibrium formula to find that. So the sum of my moments have to equal 0. I could also think about that like moment effort has to equal moment resistance. For the most part, same thing. We see that when we see that the forces are negatives on one of them and not on both. Hey folks, I am doing a video on class 3 levers now. So I have one on 1, 2, and now we're on to 3. So first thing I'm going to do, just like all the times prior to this, is I'm going to start off by drawing this thing. So it's a third class lever. And like we've talked about in the past, free, 1, 2, 3. So it's a third class lever, means my effort is in the middle. And if you remember from all the other things we've done in the past, that means my mechanical advantage cannot be 1 or larger than 1. This is not a good lever if you want to try and lift heavy weight. It's a good lever if you want to try and move very far, though. So my force effort is going to be here in the middle. My force resistance is going to be on the end, and my fulcrum on the other end, obviously. My force effort is going to be 1 Newton. And my force effort, I don't know, but I do know my distance effort, which is not really a phenomenal thing to know, I guess. I guess it's helpful, but doesn't seem like it right now. I'm just going to put 5, but it's 5 feet. And so we need to solve some things, right? There's a couple things I don't know. I don't know the force effort, and I don't know my distance to my fulcrum from my resistance. So this part here, I'm going to label that like dr, distance resistance. So first thing I'm going to do is I'm going to try and find something, right? I need my other force, or I need another distance. So I'm going to use my mechanical advantage that they gave me. They gave me IMA, or ideal mechanical advantage. So I'm a deer is how we remember this formula. So distance effort over distance resistance. And my IMA is 1/2 or 0.5. My distance effort, they gave to us. Sweet, 5 feet. My distance resistance, I do not know. So I'm going to write it as dr. Now, 1/2 or 0.5 is the same as a straight up 1/2, isn't it? That's how I'm going to think about it. So I need to cross multiply here and divide to get dr. So dr times 1 is dr. 2 times 5 is 10. My unit is now feet, because remember, IMA doesn't have a unit. So my distance resistance is 10. Awesome. I'm going to hop up in the top. I'm going to erase my dr, and I'm going to write 10. Okay. Now I need to go through, and I need to try and figure out what my force effort is. So I'm going to use static equilibrium. So my force times my distance for my resistance is going to equal my force times my distance for effort. And my force resistance is 1. My distance resistance is 10. Force effort, I don't know. So that's still FE. I do know my distance effort, though, and that's going to be 5. So now I need to kind of divide some stuff up here. And on the left side, I have 10. On the right side, I have a 5. I'm going to divide by my 5 feet. My feet are going to cancel, and I'm left with 2 newtons equals my force effort, which is pretty sweet, right? It's kind of simple. I wrote it kind of sloppily, but you know, you get the picture. None of these problems are too terribly complicated. I'm always going to either start with static equilibrium or end with static equilibrium, or do it somewhere in the middle. And I'm going to use something with my ideal mechanical advantage. So I'm trying to find all the missing pieces. The great thing is, if you started off the wrong one, let's say you started over here on the static equilibrium formula, you wouldn't know your distance resistance, and you wouldn't know your force effort. If there's 2 variables in one equation, we don't know how to solve for that at this point in the game. So I have to come over here, and I have to start plugging things into one of my other formulas. There really aren't many. We've got I'm a deer, we've got our moments, and then we have am a free, and that's kind of it right there. So as long as you're talking about levers, it's pretty much one of these 3 formulas, and you solve for the missing pieces. Plug and chug until you find it, folks. That's about it. Have a phenomenal rest of your day. Hit that like button down below. And if you have questions or comments, if you're one of my students, email me, because that's the best way to get a hold of me. But if you're not one of my students, then send me a comment down below, and I'll check those pretty often. And hopefully I can answer your questions through there or by making another video. So have a great day, folks, and don't do drugs.